Okay, now we are going to see the need of copy constructor. That when the copy constructor is required in our class. So we remember that we created a class list previously. So we'll use that example again, which we use to illustrate the requirement of destructor. So generally we need a copy constructor in a class that already needs a destructor. So let's look at the coding example. So this is the class list that has one simple constructor, typecast constructor, one destructor, and one simple method show. So in the main, we remove the previous code and start the code a driver for list class. So we have a with parameter 3, it will create an array of 3 elements dynamically inside A, and then we define a new scope and define B inside that scope, which is a copy of A, and then we say B dot show, and then we say A dot show once before that block and once after that block. And let's observe what is the problem of default copy constructor, the copy constructor that is provided by C++. And to observe this, we'll run this program in the debug mode. So we have put a breakpoint in the first line of code, and let's see the output. Okay, so the program has executed to the start of the first line, and we need to move forward by pressing the F10. Okay, so when we press F10, it completes the execution of first line and creates that list A that has size 3 and is automatically initialized and is allocated an array of 3 elements that must have the values 10, 20, 30 as per the code of constructor. Okay, we press F10 again and we see at the output screen 10, 20, 30 is displayed. Okay, and then we press F10 again to create B as a copy of A, and now the default copy constructor provided by C++ is executed. So we don't see any message, but obviously all the data members of A are copied to B. So we can observe that in this execution of the next statement. Okay, so yes, B dot show also displays 10, 20, 30, which is an indication that it is copied. Okay, and then the closing curly bracket destroyed B. So B is destroyed, its destructor is called, and which also means that the memory, the delete operator of written in the destructor of B is executed, right? So by execution of this, it will delete the memory pointed to by its P, and since P point to this memory area which was allocated by A, so it has deleted that area, unfortunately for A. It is unfortunate for A, in fact. And now if we move further, F10, oops, so here you can see that now the area pointed to by A is just garbage, is not usable for A. And let's see one more even greater problem, that if we now press F10 we will have a crash. So our program is crashed because now it is trying to call the destructor of A, and which is trying to delete the memory allocated to P, but since P has no allocation, therefore the program crashed. Right, so this is the situation where we must write a copy constructor in this class. So generally speaking, again, if we have a pointer data member in a class, we must be careful about and about realizing that we need a copy constructor and we need a destructor for this class. And if we allocate memory using new, then we must write a copy constructor and destructor for that class. Okay, so here we write a copy constructor. List is the name of the constructor, and list type reference it receives s, and now s is an object, so s dot size is assigned to size, and p is allocated a new memory, right? So instead of sharing that area, and we also write copy as indicator here, and here instead of assigning new values, we want to assign the values of array from the already existing object. So s dot pi is assigned to pi. Okay, let's execute again. Now you can see that things are fine, right? So list is created for 3 elements, then 10, 20, 30, a dot show, and then b equals a. Sim list type b equals a, which called copy constructor, and then 10, 20, 30 of b dot show, and then b is destroyed because of curly bracket, and then 10, 20, 30 of a dot show, and then a is destroyed.